So for the next one, we're still going to be using the exact same formula, but we're going to kind of sort of morph it just a little bit. So let me go ahead and show you what's going to be different about it. What I have is A equals P times 1 plus R over N raised to the NT. But this time it says I want to find the present value. Okay, so this time I'm being given A and I want to find P. So if I have $50,000 is the amount that I've accumulated. Okay, I want it done in 6 years. Okay, and I know that I'm compounding semi-annually, which is twice a year, and I want to do 3%. Okay, so at 3%, that means I've got 0.03. Okay, so we're still going to fill in all the blanks. It's just that at the end, instead of just multiplying through like we did before, I'm going to divide both sides by what I find in these parentheses and exponent. So I want 50,000. That's going to equal P, 1 plus my rate, which is 0.03, over my N, which is number of times that I'm compounding, so that's 2. And then raised to the NT, so twice a year for 6 years means I've got 12 compounding periods. So all I'm going to do is divide 50,000 by this mess right here. Okay, so in my calculator, let me show you what it's going to look like. I'll have 50,000 divided by 1 plus 0.03 divided by 2 raised to the 12th power. And what I get is I started with an investment of 41,819. Can you see that? There you go. So 50,000 divided by all of that. So I started with 41,819 and 37 cents. So 41,819 and 37 cents. That's how much I started with. So we're just kind of sort of working backwards to find out what that value is. So the second part of that equation, so again, we're going to use the same thing. So I have A equals P times 1 plus R over N raised to the NT, but I want to find what I started with. So the value I have accumulated is 50,000 still, but this time I'm at 3% per year. So that's 0.03. I'm compounding quarterly, so that's 4 times per year. And then I have in 6 years. Okay, so I can go ahead and fill this in. I've got 50,000 equals P times 1 plus my rate, which is 0.03, divided by 4 times per year, raised to the 24th power. So again, I'm just going to do 50,000 divided by, and then type this in my calculator. So what you're really doing is you're dividing both sides by 1 plus R over N to the NT. So it disappears from this side, and it'll show up here. So in my calculator, I'm going to do 50,000 divided by 1 plus 0.03 over 4 raised to the 24th power. So 50,000 divided by 1 plus 0.03 divided by 4 raised to the 24th power gives me 41,791. And 57 cents. Okay, so again, we're just kind of sort of working backwards. We've got a different unknown, but we're still using the same equation. So, same type of thing. I want to find the present value of $60,000. Okay, so that means I have accumulated 60,000 and I want to find the present value. Okay, after 5 years, I'm sorry, after 6 years. So 6 years. And then I have 6% per year compounded 0.6, and I'm compounding monthly. So that's 12 times per year. So fill this thing in. I've got A equals P times 1 plus R over N raised to the NT. Well, this time I've got 60,000 equals P times 1 plus R over N, which is 12, raised to the NT, which is 72. So again, I'm just going to do 60,000 divided by everything else. So 60,000 divided by 1 plus 0.06 over 12 raised to the 72nd power. So up here on the previous ones, we were multiplying. Well, now we're just going to divide because I want to know what the present value is. So 60,000 divided by 1 plus 0.06 over 12 raised to the 72nd power. Oh, I messed up. Hang on. 1 plus. Here we go. Gives me 41,898. So 41,898 and 15 cents. Okay, same scenario, but we're going to change the compounding periods and we're going to change the interest rate. So I'm at $60,000. That's how much I've accumulated. I need to know what I started with. I'm going to do 9% per year, which is 0.09. And I'm going to be doing this for 6 years. And I'm going to be compounding daily. So remember, unless you're told otherwise, use 365. So I have 60,000 equals P times 1 plus R, which is 0.9, over N, which is 365, raised to the NT, which is 365 times 6. So remember, you're going to have to use parentheses around that exponent. So in my calculator, I will type 60,000 divided by 1 plus 0.09 over 365, and then I'll say raised to the 365 times 6 in parentheses. Okay, can you see that? If you can. All right, so 60,000 divided by 1 plus 0.09 divided by 365 raised to the parentheses 365 times 6. And I get an answer of 34,967.22. Okay, so 34,967 and 22 cents. So you're just working backwards. This is how much is in the account at the end of 6 years. This is how much is in the account. This is how much is in the account after 6 years. But what did you start with? That's what we're trying to figure out in this one. All right, so for number 8, we're going to talk about continuously compounding. So we've noticed that we can do annually, semi-annually, quarterly, monthly. We could do weekly, daily, hourly, whatever. But when you see the word continuously, that means stop the world and change your formula. When you see the word continuously, that implies that you need to deal with E. And E is a constant. It's like pi. Okay, it generates for all eternity, never stops, never falls into a pattern of repetition. So it's an irrational number. But just like pi's job is to play with circles, E's job is to play with money. Okay, so E's job is to play with money. So as soon as you see that word, you immediately say, okay, this is my new equation. So I have the amount accumulated equals the present value, or achieved equals principal, times E, which is a number, raised to the R times T. Okay, so I want to know if I'm investing $3,000, so that's my present value, at 4% per year, which is 0.04, compounded continuously, and I want to do this for 5 years. So my value is going to be, well, how much do I get in my account? 3,000 times e raised to the 0.04 times 5. So remember to put that exponent in parentheses. So that's what I did on the last one. I said I was going to show it to you and I forgot. All right, so I had 60,000 divided by this mess and then raised to the, your exponent needs to be in parentheses. So this one is going to be 3,000 times e. So your e button, mine, you have two of them actually. You've got one right next to the natural log. If you can see that, it says e to the x. Or if you just need e, you've got another one just over here. Okay. Well, I need e to the x because I'm dealing with an exponent. So I have 3,000 times e raised to the, and I've got 0.04 times 5. So that exponent is in parentheses. And that gives me 36, 64, 21. So 36, 64, 21. So that's at 4% compounded continuously over 5 years. I mean, just by not touching that $3,000, you just increased it by 664. All right, couple more. We have an amount of $35,000 is deposited in a bank that pays interest at the rate of 3% per year compounded annually. What is the total amount on deposit at the end of 7 years, assuming that there's no deposits or withdrawals during those 7 years? Okay, so I'm starting with, I have A equals, I didn't see the word continuously, so I'm going back to my other friend. Okay, and I have $35,000. And I'm doing this at 3% per year, which is 0.03. It is compounded annually, so that's once per year. And then for how many years am I doing this? I'm doing this for 7 years. So I have A equals 35,000 times 1 plus your rate divided by 1. So it's just your rate, which is 0.03, raised to the 7th times 1, which is just 7. So 35,000 times 1 plus 0.03 raised to the 7th power gives me $45.59. Okay, so that's how much is in my account at the end of 7 years. Well, I would like to know how much interest I earned. So if this is my principal, and I was paid interest, and I have this amount, then all I have to do is subtract off my principal, and I will know how much interest I earned. And I earned $8,045.59. Okay, so that's how much is in the account. We're not going to count this part because that's what you deposited. And then this is how much interest I earned just simply by not touching it. Okay, so the last one for this section is the present value of an investment. So Jada deposited an amount of money in a bank 6 years ago. If the bank had been paying interest at a rate of 8% per year compounded daily, assume a 365-day year, and she has $18,000 on deposit today, what was her initial deposit? So this is the exact same format as what we were doing before with these. I know how much I've got now. I need to know how much I had to start with. So I do know the amount that she's got right now is $18,000. I do know that my interest rate was 8% per year, so my rate is 0.08. I know it's compounding daily, and I know that I did it for 6 years. So again, I am solving for P. So I have 18,000 equals P times 1 plus R over N, which is 365, raised to the NT. So that's 365 times 6. So remember, in your calculator, you're going to do 18,000 divided by, and then we'll have 1 plus 0.08 over 365 raised to the, in parentheses, 365 times 6. Okay? Okay? So I have 18,000 divided by 1 plus 0.08 divided by 365 raised to the parentheses 365 times 6. So I found out that Jada started with 11,138.69. Okay, so those are practical applications of exponential equations. And so in the next couple sections, of course, we're going to start doing derivatives and that type of thing. So I will see you in section 5.4.